Okay, hello everybody. This is Professor Iris Miano. I'm going to be giving you a construction demonstration straight out of section 5.4, Basic Constructions Justified. Of course, you need your usual tools here. A straight edge, I use my floppy ruler, and I have a mechanical pencil, and of course I have my trusty compass. So in being able to tackle anything that's going to come your way in the homework set associated with section 5.4, you definitely want to remember all of your previous construction demonstrations. So there were 7 of them. If you recall, construction 1 was constructing a congruent line segment. Construction 2 was the midpoint construction. 3 was a congruent angle. 4 was an angle bisector. 5 was a perpendicular to a line through a point on the line. Construction 6 was a perpendicular through a line, or to a line through a point not on the line. And construction 7 was a parallel line. So all of those things are definitely fair game to be combined with other things, reiterated in some spectacular way for 5.4. And then there's another one that you're going to need to learn, and it's going to be, so basically I am referring to page 269, example 4. So the instructions are there and everything, but I think it's kind of nice when you can rely on an actual like step-by-step demonstration to see how to make a 60-degree angle. And then we're also going to bisect it to give you a 30-degree angle. So this will be a little bit of a review on the angle bisector procedure, but then also we're going to, in the midst of making this happen, create a 30, 60, 90 right triangle. Like, we have some real cool stuff coming out of this. There's a lot happening. So in the first thing that we want to do is give ourselves a line segment, okay? So it's going to be some particular length. How long do you want to make it? Oh, I don't know. Not too long, because you want to be able to have your compass be able to open far enough to encompass the entire length of the line segment that you create. So just make it something somewhat reasonable. I'm going to start by putting a point right there, and I'm going to line it up horizontally and make it, I've decided I'm going to make my line segment this long, because I'm fairly certain that my compass can encompass this distance. Now, so the first step that you take after you draw your line segment, let's go ahead and name the edges. I always like to do that. Let's name them A and B so far. Let's open up our compass such that we capture this distance, and I'm going to have to open it up pretty far, maybe close to the maximum length that it can handle. Ooh, yeah, this is getting, oh, here we go. I overshot it a little bit. So definitely my compass can handle this particular length. And it looks like that I've captured it. Does that look pretty good right there? All right, and if you're ever in doubt, just go ahead and draw a little arc and make sure, oh yeah, I'm going right through the point that I want to, and I'm centered at the other end point. So the way that you make this 60-degree angle, that's going to be the first thing that we try and tackle here, is just draw a first arc. You can make it a quarter turn, like a quarter of a circle, and get real crazy with it. Ultimately, you just need to capture the area kind of approximately halfway between A and B. You're going to keep the same distance from A to B, but now turn your compass over such that you are centered at B, and you can be real minimalist about it and just draw an arc such that you intersect with that first arc, like so. You just want to capture this point right here, the intersection of the two arcs that are drawn, centered at A and then B, or vice versa, in which the radius is the distance of the line segment you drew. So I've captured that intersection point. I'm going to call it C, okay? Sure. And so go ahead and draw a line segment either connecting A to C or, you know, B to C, it doesn't matter. But you will be capturing your 60-degree angle. Like, I am certain if I had a compass here with me and if I wanted to measure it, this one would be 60 degrees. And also notice that the distance from B to C would also be that same distance of the original line segment. So if I was to draw this line too, I would have another 60-degree angle here, 60-degree angle here. How do I know this? Because my compass has made all of these line segments that I drew with my straight edge the same length. So I've created an equilateral triangle. Equilateral triangles are also equiangular. Equiangular triangles have interior angles that are congruent to each other and therefore all equally measure 60 degrees. So there's your 60-degree angle. Check on that. Let's go ahead and bisect one of these angles. Maybe not the one that I, what's it called? Not the one that I labeled here. I'll go ahead and bisect angle B, just because, you know, the area over here in the interior of angle B is clear. So the first thing that you want to do is can you capture the distance from A to C? You do not want to do that. You want to make it somewhat shorter. So how much shorter? You know, dealer's choice. Just make sure that you are capturing some distance within the length of line segment from B to C, or, well, any of the edges of the triangle that you've initially put. So I'm going to go ahead and choose this distance right here. So centered at B, I'm going to go ahead and draw an arc that goes through below line segment AB, goes through it, inside the interior of angle B, and then crosses line segment BC as well. So go ahead and just go like that. Okay, cute, right? Note the two places in which that third arc, now that you've drawn in this succession here, intersect with line segments BC and BA, or AB rather. So we can continue with the letter scheme if we want to, and call this what, D and E. You want to go ahead and keep this same distance if you want to. There's no need to change the distance of your radius at this moment. Just in the interior of the extended idea of what angle B is, go ahead and draw two more arcs centered at both D and E such that they intersect with one another. Okay, so I'll show you what I mean. Here's centered at D. You guys all see that? I'm going to draw an arc. Okay, that's plenty of arc right there. And then pick up your compass, keeping that same radius, now centered at E. Go ahead and intersect with that. Ooh, so I almost intersected the intersection of those two arcs with line segment AC. That's not necessary by any means. You just want to be able to capture the intersection of these two arcs, which is right here. Okay, and you're going to draw an edge such that you connect, what is this, F is the next letter, and you're going to draw a ray BF if you like. Isn't that cute? BF, best friends, or boyfriend, right? I don't know. BFF would be best friends forever, the acronym. Okay, so there we go. So there's ray BF, cool. Now you can also make sure that the intersection there, we can call that another point, or you could just slide that down a little bit and just call F the, yeah, let's go ahead and just slide it down a little bit and call this point F right here. Just say that it intersected with not only the two rays, or sorry, the two arcs, but it also intersected with line segment BC. Cool. So since we know that this BF ray is an angle bisector, we know that these two interior angles are congruent to each other, and since we know that the collective angle CBA is 60 degrees, right? Same as angle A over here. These interior angles that resulted in the incorporation of the angle bisector BF. In fact, I'll just go ahead and label ray BF as an angle bisector. So again, and I'm using the procedure associated with construction 4. And I know that they are each 30 degrees, right? 30 degrees here, 30 degrees there, cute. Okay, now check this out. An interior triangle has been constructed with the incorporation of this BF angle bisector. This angle inside of triangle BAF is 30 degrees. This angle is 60 degrees. What has to be the measure of this angle over here? Well, it's got to be 90 degrees. So I can go ahead and put a box inside the interior of angle BFA in order to indicate that it's a 90-degree angle. So there, I've done my 30-degree angle, checked there, and I've created a 30, 60, 90 right triangle in the form of triangle BAF, LOL, is one such, this triangle that I made here, okay? Great. So if you ever were in the market for creating a 30, 60, 90 right triangle, this is a procedure that can get you there, all right? And it all stemmed from example 4's material, which technically, if you're looking at the instructions there, it's the mechanism by which you would create a 30-degree angle. But there's so much more going on, as you can see. And so this is the extent of what I see as being useful procedures that lend themselves from simply trying to create a 30-degree angle. That is it for now. Thank you so much for your attention. I'll see you in class very soon.